Hello everyone, welcome to my video. In this video, I will talk about how I structure production Go project. Um, so let me show you something. So whenever you are writing any Grow project, right, you must be asking maybe from a AI tool or looking in Google like how can you structure a uh, Go project, and this is the GitHub link you might have come across. So if you see, it has over 50,000 stars. But here is the thing, right? Actual person, actual Go team at Google. So Go is developed inside Google. So filed an issue in this particular repository saying this is not a standard Go project layout. And the official Go docs literally says if you that there is no single right way to structure a project. So if the most popular guide isn't actually a standard, what do you use in production? This is the question. That's what I am going to show you. I am going to walk you through the exact structure I use for every production Go service with real working code. So by the end of this video, you will have a template you can copy for every new project. So let me go here. So I already have written the code. Let me show you the structure of this directory. So here is the full structure. Let me walk through every single folder and why it exists, not just what goes in it, but why it need to be separated. So if I open this file, starting from, let's start with main.go, which is inside which has a folder CMD, and inside that I have created another folder called a server, and then it's a then we are starting the our main basically entry point of our code. So this is your entry point. The main function should be thin, right? If we see this main function, it's quite thin. It does three things. It loads the config, um, wires up dependencies, and start the server. That's it. No business logic, no HTTP handling, nothing. So uh, so what it is doing is loading the config. If you see this, then wiring up the dependencies, we require database and all those things, then starting the server. It is just starting the server. You see, uh, where is it? Yeah, it is starting the server, right? So that's it. It's a very thin uh it's very thin. So look at how I wire the dependency, right? I create a repository first. uh, Let me show you this. I create a repository first. I pass it to the service, pass the service to the handler, everything flow in one direction. So handler depends on service, service depends on repository, never the other way around. So this is an example for that, right? If you see this, I created a repository, passing it to a service, then I'm passing then I basically I got a service, then I'm passing this service to the handler, right? It's a one way flow. So if you see right now why this and if you notice right now is we are using in-memory user repo right now. Right now it's an in-memory store. Uh, let's suppose if tomorrow instead of using an in-memory database, you want to use Postgres or you want to use any other database. So you can just swap this particular line of code and everything will work as it is. You don't have to make a lot of changes in the code. So now let me open the second part, which is how I create the model. Let's go to user.go. So this is the inside internal folder. Yeah, it's it's in the internal folder. We have created a folder called as model, and inside that we have a file called user.go. Here we are creating the user models. This is where your domain type lives. Your user struct, your request type, your custom errors. Two important thing here. First, let's see the create user request. This is separate from user struct. Your API input type and your domain type should never have the same struct. Your user have an ID and created it that comes from database, but that is not present in your request itself. And second, if you look at errors.go, um, I define all my domain error here as a package level variable. So if you see, if I have to use it, if you see error user not found, error email taken, error email required, error name required, this is the important because it lets every layer in the app check error with errors.is. So we have error.is provided by Go itself, uh, which checks whether the error matching this. So we use this without importing each other. This keeps the error handling clear and clean. So this is about model. Then let's come to the repository part. So if you see this, now this is the repository layer. This is where I want you to pay close attention because this is the pattern that separate production code from the tutorial code. Okay. So look at the top, I define a repository, right? And this is a repository interface. So what is an interface is that I am saying if someone is using this particular repository, it should have access to these methods, right? So it have what methods are those? Like it is create, it is get by ID, get by email, and list. The service layer depends on this interface, not on a concrete implementation. So when I'm saying in a service layer, if I'm using this repository, so I'm saying the service is dependent on this particular repository. So if you see, I might be saying s.repo.create. So what I'm saying is service is calling the require a create method of repository. But the actual, I'm not using the concrete implementation. I'm using the interface. So below it, if you see, I'm basically to implement that interface. Uh, let's say if in-memory user repo is implementing that interface, it has to define all these methods that are present in the interface. So this in-memory user repo satisfy that interface. In production, let's say you have a Postgres user repo, right? Instead of in-memory user repo, uh, you can directly swap it. Basically, you can create a similarly how we have created in-memory user repo and basic and um, creating methods uh, for creating methods like create, get by ID, get by email, and list. Similarly, you can create the same method for Postgres, and you can say that this particular struct is implementing that interface user repository, and you can directly use the Postgres instead of in-memory DB. So if you go here in go right now, how we are using in new in-memory user repo, you can use the Postgres and pass that Postgres instead. Because if in this place we are just saying that it is when we are creating the service, we are saying it requires a user repository. So if your particular struct is implementing this interface user repository, then you can then the flow will work as it is. So let's show one more thing. So uh, and you see this line at bottom, right? This is a compile time check. If any in-memory user repo is missing any method from the interface, the code won't compile. So I would advise you to use this in the project wherever you are using, wherever you are writing anything in Golang. So let's come to user service. The service layer, this is where your business logic lives. And I want to highlight what's not here. There is no HTTP request, no JSON parsing, no status code. This layers know nothing about HTTP. Why does it matter? Because tomorrow when yes, your product manager comes to you and says, We also need a gRPC endpoint, uh, remote procedure call endpoint, or we need a CLI command that create user. You don't have to rewrite your business logic. You just have to create a new handler that calls the same service, right? Let's look at the create user, right? It validates the input, correct? We are validating the input, check for duplicate email, uh, creates the user. Simple as it is. It is just not doing anything apart from uh, the business logic. So that's why it belongs here, not in your HTTP handler. And also notice the limit endpoint. Let's show you. Right now, I don't have list user here, but oh, I missed adding the limit endpoint. But let's let's forget about it. But yeah, generally this is how you write a service layer where you are just writing your business logic. No HTTP request, no JSON parsing, no status code. Now coming back to the handler part, uh, let's come to handler part. So in the handler layer, this is the thinnest layer in the whole app. All it does is parse the HTTP request, call the service, write the HTTP response. That's it. So it has a particular role. It gets the HTTP request, call the service, write the HTTP response. That's it. Let's look at the create user handler. So what does it doing is decodes the JSON body, right? Call the user service and uh, and then map. So it will map the domain error to the HTTP status code. So this is what happening here. Uh, so this domain error to status code, this mapping domain error to HTTP status is the only job of the handler. If you are writing if email equals to nil in your handler, that's a business rule that belongs to the service. So one more thing, I'm using sure which Go. I'm using 1.22 Golang. Uh, Golang's new routing with method like to the user. Yeah, I'm using this Golang 1.22's new routing with method patterns. So post users and get user by ID. No need. We don't require gin or G for simple API anymore. Standard library is enough. So it's fine if you're writing a simple API. So you don't require any other any other framework like G not G. So you can just use the standard library. Let me show you the config part. What does it contain? Config is a simple but important thing. Uh, it loads from your environment variable right now. You can also use a config.json also and parse that file to load your config.go. But for right now, for this particular demo, I am just using the environment file. You load it from the environment variables, provide sensible default variables. Uh, for development, validate the required value exists, right? and and every production service need this. The key thing is we should never hard code a port number or database URL in the main.go. It should come from the config itself, because let's say if you are running the code in the local, it would have a different password for or different database URL, different port compared to when you are running it in sandbox and then in production. So all these values should come from your environment variable or maybe from some config.json file, whichever suits you. Then there is a Docker file. Let's let's quickly look at it. So what are we doing here, right? Let's see. If you see this thing, correct? We have two from statement here. So it's a multi-stage build. The build stage, right? it is uses the full Golang image, right? To compile uh, to compile this code. Then the run stage, which is this stage, uses Alpine. So the final image is about 15 megabyte instead of 1 gigabyte. So the reason being is it has everything that is required to build a Go binary. Then once the binary is there, we copying that binary to the runtime environment, and we are using Alpine. This helps in keeping the final image to have, requiring less storage. So as I said, somewhere around 15 megabyte, it will your final image will be of somewhere around 15 MB instead of 1 GB. So always do this for production. The reason being is that whenever you are deploying anything in production, the size of image also determine how quickly you can able to deploy. So yeah. Anyway, if we are try to keep it to minimum size. So this is a best one of the good practice you can do. Then we also have makefile here. Uh, and the makefile, we have the four commands here that you will use every day. That is make run for local development. Then you have make build for binary. Then we have make test to run the test. Then we have make lint for linter. Every new developer on your team runs make run, and whenever they do it, it's the server is up and running. So yeah, that's it. Let's see if I can run it. Sorry for. Uh, hmm. I will see. Right now it's not working, but there might be some issue. I don't want to waste time here to fix it and make it work. But this is how I generally structure the code base. So let me go again and so to recap, right? So to recap, CMD CMD is an entry point, thin main function which wires everything. Internal models your contains your domain type and error. Then the repository contain data access, which is interface driven. So yeah, your service does not know about your concrete type. It knows only the interface. It knows that okay, these are the methods that I can use from the repository. The how that method is working, that is up to repository to define. So then comes to your service, which contains the business logic. Uh, it does not contain any HTTP knowledge. Then the handler, which is an HTTP thin layer, just parse and respond. Then we have a config, which contains the environment config. We also have migration here. I forgot to show my. So this is where we put all our migrations. Um, it contains the SQL file. Then we have Docker file, and then we have make files, which is required for deployment and dev tooling. The one rule to remember, dependencies flow down, right? Handler calls service and service call repository. So if I go again to main.go, if you see this, the dependencies are flowing down, right? So handler is calling service will call the repository, right? So never upwards. And the biggest mistake I see, like people are doing a lot of over engineering thing for small project. So if you have 3 or 4 endpoints, you don't need 15 folders. Start flat, extract packages when you feel the pain, but when your project grow, this is the structure that scale. So I package this exact, so I will upload this in my git repository, in my github, and share the link. So if this helped you, please hit subscribe. I'm posting a new Go video every single day, or maybe uh, twice in a week. It's a little bit. I'm sorry, I'm a little bit inconsistent. So next time I will try to cover some error handling thing, or maybe something related to AI. Like last time I covered how to build an MCP. So drop a comment telling me how you structure your Go project. Uh, I want to know, and let's see you in the next video. Thank you.